This is amplitude, this is a frequency knob. No, this is string. The wave is propagating like this. Okay, no. The power of a wave. I'll increase frequency. What will happen to the power of a wave? Will it increase? What are the formulas we have? Power is given by now mu omega square a square v by 2. Mu, no, mu will come. Intensity is given by. Now I'll increase frequency of a wave. How to increase frequency? By turning this knob, I can make this to vibrate. It will take less time to complete one oscillation, point on a rope. That's nothing but the frequency. By varying frequency of source, what will happen to the power of a wave flowing on a rope? Will increase. Agreed? I'll increase amplitude knob. So this amplitude. So as I increase amplitude, so indicate all. So what is amplitude? This amplitude. This will be your mean position, no? So the amplitude will increase. So as you increase amplitude, power will increase. Then I will increase the load here. If I increase the load, tension will increase, no? Good idea. If tension increases, speed of a wave increases, because what is the speed of wave? Speed of the wave depends upon these things. Okay, no, so try to see this. So if I increase the load, tension will increase. If tension increases, yes, the speed will increase, the power of a wave will increase. Got the idea? Now come for the material as copper string made up of iron, copper, aluminum. So different materials, the rho will change. Proportional, the speed of wave will change, power will change. The thickness also matters, no? By varying the thickness of a rope, S is what? S is a pi r square. I'll make it, say this is what happens in exams. Students will think something very different. So this will be, diameter will be 2r, no? So what is S? S will become pi r square. If I increase the radius of the rope, if I increase the radius, wave speed will decrease, power will decrease. So in books, you have question, like a person will generate a transverse wave on a two ropes. One is having radius r, other is having 2r, where the power flow will be. Both are made up of same material. Both the waves are set up by same source. So omega a will be fixed over. Both are of same material. Mu will be same. Since the radius matters, no? Where radius more, the waves will be less. Wave speed less, power less. So what actually this rope is doing? Anybody wants to answer? Shall I say it is transferring mechanical power? Simplest thing. What is the conclusion of this chapter? Why I'm using this rope? I can transfer mechanical energy from one point to another point. I'm able to transfer the energy like we have electrical wires. Now, what electrical wires will do? They will transfer electrical power from one point to another point. Electrical power, the electrical power itself will get transmitted. I square R, that's the electrical power. Here what happened? The rope, what is the role of the rope here? This will generate mechanical energy because from where this energy will come? Electrical power. So I'll connect this to switch. When I switch on this button on, the rod starts vibrating. Then what this rod and rope system, the vibrations of the rod will be converted into mechanical energy on a rope. The mechanical energy will flow on a rope, and the energy which is present here after some time will come. So what is the role of this rope? It will transfer mechanical power from one point to another point. That is the conclusion of this chapter. Sir, where do we use? We use this in industries, or you can say in the lot of lifting higher equipments, everything. No, we do use this one. So what is the role of the rope? Rope here or string. String transfers mechanical power. The string transfers mechanical power. That's it. That's all here. And where do that the energy is flowing in Europe? In what proportion? Both will be in equal proportion. And that one. So how much U and K? U by K will be 1:1. Now I want to know the energy present in a length of the rope. What shall I do? I know energy density. I'll multiply with the volume of a rope. I'll come to know how much of energy is present. Then how much of energy present in one cycle? What is one cycle? One cycle means this one. No? What is the length of one cycle? Lambda. Then energy density into area of cross section into lambda. That will give energy present per cycle, or energy flowing in per cycle of the rope. How much of energy present in one cycle? One cycle will become lambda, no? Then what shall I do? How much of energy present means energy density into volume. These are all things which will be available for you in the book. This will become lambda, or you can also call this as one cycle. This one. So what is energy now? Energy of a wave per cycle. So what shall I define? Energy density into volume of a rope. Energy density formula we know, rho omega square a square v by 2. I think this will be correct, no? Formula mu rho omega square a square by 2. V will not be there, energy, no? And what is the volume of the rope? Area of cross section into in for what is for one cycle, what is the length of the rope will be equal to lambda. Further what you can write it as F equal to V lambda. Further F what you can write it as omega by 2 pi. Let me write those things. F equal to and omega equal to 2 pi f. So therefore, in place of f, what we can write? Omega by 2 pi. In place of v, what we can write? Omega. In place of lambda, what we can write it as? Two get cancelled, so this will be rho s omega a square v by 2. Pi will be there. This is some e dash, any other symbol, or you write it e lambda. These are the different types of things will be asked for you. Energy of wave per cycle means in what is per cycle? What is the length of per cycle will be lambda. Okay, got the idea? So this is about the energy of a wave propagating on a rope. So these are all set of formulas are there. Okay, now there are